Okay, so hi everybody. Today it's a great pleasure for me to introduce Professor Farcomeni from University of Rome Tor Vergata. Professor Farcomeni is an expert in many methodological aspects of statistics, in particular quantile regression, robot statistics, the applications to biology, healthcare, and recently worked a lot on COVID-19. Is working on many social aspects of many applications to the social sciences and biology, as I mentioned. In particular, today is going to talk about something which is a very important topic for us. Now I'll go into details of that. He has spent most of his career at Roma Tor Vergata, Roma La Sapienza. He did his master at Carnegie Mellon and is currently professor at Roma 2. He's an highly cited scientist. He has been referee for many important journals, published in many important journals, both methodological and applied. There is a lot we can learn from him, and in particular, one of the aspects that I think is very interesting for our audience is this topic of estimation or population estimation in relation to immigrants from Africa to Europe. It's a news of these last days of well, I mean, these things happen every day there. We talk not that much here in the US about them, but main news on Italian newspapers today and yesterday is the death of 64 refugees at the coast of Crotone. Crotone is a major city in Calabria, in south of Italy. So it's a great problem. We under-discuss this in the US. And I really want to hear what Professor Farcomeni has to say about statistical methodology in applications to this problem. Thanks a lot for being here with us today.
Thanks for the invitation. It's really a pleasure. So I'll discuss this application and the methodologies that I have developed to investigate the number of migrants and refugees that died in trying to reach Europe. If you have any question, interrupt me at any time. It's not a problem. Really, we discussed that we will have time for questions at the end. But if you need more explanations, if you get lost, don't worry in asking. And so I'll start with introducing the problem from an epidemiology, public health point of view. So migration regulation and what it brings about as a public health issue. This will lead us to the need to develop a simple methodology for estimation of jointly population size and a total, and I will define in this specific application what they are. Let me stress that population size estimation is a very lively area of statistical methodology, and so what I'm about to discuss can be applied more broadly. So I will introduce my methods. I will show you a simulation study to convince you that it should more or less work, and then I will give you the results and a brief discussion about what they imply. So border control and immigration is an hot topic in the political debate, especially around election time, and this is true anywhere in the world. Italy is sort of in a very central place in this debate for several reasons. The main reason is that Italy is the first place to be reached from the sea, going north from Africa. So also Greece experiences a lot of people coming from Africa, let's say illegally to understand each other. But from Libya, which has got a very complicated political situation now, the number of migrants is much larger. It's widely acknowledged that the policies of member states make it difficult to enter Europe legally and safely, and whatever are the regulations, this leads to a public health issue, meaning that people die. And I will show you some numbers. The number of deaths is incredibly large to me. Clearly, this happens without a control of the process, because people are trying to enter Europe not legally and not safely. So the deaths are not necessarily recorded. There are official tolls, but the question arises: how many people died while trying to enter the European Union? And what is the extent of undercount in these in the official statistics? Motivation comes mostly from the fact that it is widely acknowledged that the true number of deaths is higher than the official estimates, and so how much higher. There is an issue with the differential evolution of the process, meaning that if you monitor the number of deaths that you can record, and the proportion of undercount is more or less constant over time, then you can get the trend. But if this proportion is not constant over time, then you might see a trend in the observed data, which is different from the true trend, because your extent of underestimation over overestimation is changing over time. So the real and observed trends can diverge. Okay. So, and that was my main motivation. Actually, that's not the case here for this application, but we'll see later that more or less the extent of undercount, at least in my data, which is a very peculiar data set, is more or less constant over time. Anyway, this is widely acknowledged that there is undercount. So what is the true toll? That's my main question. I have two additional critiques. The first is timing. The official estimates involve lags of at least 1 year, even more. So people that died 3 days ago will be counted in the official estimates not earlier than the end of 2024. And this clearly does not allow policymakers to make decisions, and the debate, which is political and public, to be informed in a timely manner. This was particularly important in 2015 when there was a lot of illegal immigration from the east in Europe, because Turkey opened the borders to put political pressure on Europe, and at times of war, because clearly war is a strong motivation for people moving. My second critique is with the assessment of uncertainty. This applies very broadly. Official estimates by official institutions often lack assessment of uncertainty. So they do not report confidence intervals or standard errors, and their numbers are treated as if they were not estimates but actual measures. And this is, I think, an issue quite general with official numbers. Let me tell you about the data at hand, and maybe if you have time, I'll tell you also how I got hands on this data set. So there is a club of organizations across Europe that's called United for Intercultural Action. And among other things, they collect a database of events. I will call the events any occasion in which at least one man, woman, child died in an attempt to cross a border. They record events only involving Europe. I have other data that are worldwide, but these are just European, and they update every year in May. So in 3 months, we will have updated data until 2023. So I have data from January of 1993 to May of 2022. For each event, I have the number of casualties, so the number of people that died, and a list of media sources that reported the event. And that is what allowed me to do the estimate. it. I'll get to that. The events are clearly mostly shipwrecks in the Sicily Canal, meaning from people starting, as I said, from Libya, trying to reach either Sicily or Malta or Sardinia. But also the route in the Canary Island is quite often used, connecting Mauritania to the Canary Islands, which are islands in the middle of the ocean that belong to Spain, and in the English Channel, that is the channel connecting France and the UK. Let me say that I'm talking to an audience of in the US. Let me say that most of the time people are trying to reconnect with families, with friends working in Europe, and Italy is the first place they touch in Europe or Spain, but that's not their final destination, their final intended destination. So they try traveling across Europe, and sometimes they have troubles when they already are in Europe, so from France to UK. Even if UK is not Europe anymore, but that's another story. I have 5,795 events in the past more or less 30 years, and the number of documented deaths is 48,000. And media sources are quite a lot. It's almost 2,000. Okay, clearly you can imagine that for an event having more than 1,000 deaths, it was a ship. That's the most deadly event in the past 30 years, April 19th, 2015. There are several media sources, while most of the events, more than half of the events, involve just one death, and those are reported just by one or at most two media sources, maybe local. 76 events have more than 100 casualties. As I said, the maximum is 1,100 in the Sicily Canal in 2015. Okay. Yeah, first of all, let me motivate further what I mean by underestimation. United Data is data collected by private citizens that form a consortium of associations. And for instance, for the period 1998-2011, they record 15,700 deaths. Okay, just by looking at the media, just by monitoring the media every day, they recorded 15,700 deaths. The official UNHCR estimate is 13,500. And this is not affected by the time lag. So the official estimates are clearly underestimating something that could be estimated more easily just by looking at the media, just by monitoring the media. And it's obvious that this is also an undercount, because it's obvious that there are events that are not reported by any source, or that at least people at United have not been able to record in their data. Maybe there is a newspaper, a very local newspaper in Catalan that they were not able to reach, and that has reported events. So my estimate is 18,000 actually for that period. Similarly, there is a paper by Expert in 2019 estimating 15,000 deaths for the period 2014-2018. The data records 17,000. So there is a 2,000 difference, and the estimate is 18,300 more or less. Okay, so the data I have is admittedly, clearly, obviously underestimating, but it's underestimating even the extent of the phenomenon even less than official or at least estimates, or at least estimates that have appeared in international journals, scientific journals. So how can we get an unbiased estimate? That's my that's my target. Now, if you wanted to count the number of unobserved events, that would be standard. So this is a classical problem now in statistics. It's beginning of the 20th century. It has been solved for counting the number of fishes in a pond. And in the 1700, it has been used for correcting the France census for undercount, I think it was. There are several possible estimators. I like Chow's estimator for various reasons, which I'm not going into. Chow estimator was extended to covariates by Dagmar Böning and colleagues, and by myself in 2018. I have a paper in biometrics on that. And so what's the key idea? That is based on the counting distribution. The mere fact that I have more than one media sources, and that the more media sources I have, the more visibility I have for the event, allows me to estimate the number of events that are never reported in my data, because there are no media sources that I monitored reporting the event. Okay, and the idea is very simple, and it's similar to the discussion I was doing at the time I was discussing the number of events and the number of deaths, meaning that events that I don't have in my data are probably similar to events that are reported just once or at most twice. Okay, while an event that I have reported 200 times is probably different, and it's probably connected to more deaths. Okay. So I'm just using the basic Chow estimator, even if I have a version of the analysis with covariates, but just to keep things simple, one other appealing thing of Chow's estimator is that it's closed form. So I have 1900 events that are reported by a single source, and 1300 that are reported by two sources exactly. Okay, and Chow estimator is simply given by this formula. These are the events I have observed, small n. These are the events that are reported exactly once, squared, divided by twice the number of events that are reported exactly twice. Okay, and if you do the math, it's 7,000. Okay, and there is a formula, closed formula also for the standard error, which is 79 here. Okay. So I can say that 5,800 divided by 7,100, more or less, I observed 80% of the events. Okay, so and that's a standard calculus in population size estimation. We can do better, we can do worse, we can do discussion, but more or less there is not much sensitivity actually in the data. More or less, I get 20% of undercount for the number of shipwrecks, not for the number of deaths. Okay. So in the periods, there are more or less how many? 1,000 and a little more shipwrecks that I have not been able to count. Okay, each of these is associated with a certain number of deaths. Okay, because I'm just counting events with casualties. Clearly, there are many more attempts to enter the EU, which fortunately are not associated with casualties, and these are not included in my count. Okay, so the number of boats going from Libya to Italy is many more than 7,000 in the past 30 years. So I estimate that 7,000 of those boats and clearly other circumstances led to at least one death. Okay, now the second question is a bit more tricky, given meaning that there is no there are no methods in the literature. There were no methods in the literature at the time I was playing with this data to answer this question. So how many deaths? So the number of events, the number of shipwrecks is capital N, and I've recorded small n. For each event, I have xi, which is the number of deaths. Okay, and the number of deaths I can observe, 48,000, is this small s. Okay, the sum over all observed events of the number of deaths. What I would like to estimate is actual capital S, actually. That is the sum over observed and unobserved events for the number of deaths. So this is the total I was talking about. I want to jointly estimate the number of events and the number of deaths, because those are the two parameters of interest, and they are unknown and they are clearly undercounted. Okay, so the death toll is the sum over observed and unobserved events. Each of the events that I have unobserved is associated with a distribution when you put them together of number of deaths. Okay, which probably is concentrated on one death, but maybe even more. Okay, and actually, I estimate an average for the unobserved events. I think of about three deaths, average. The median is 1. Okay, so and there are no methods in statistics to solve this issue. There were no methods. I thought about it, and actually, even if I couldn't find any instance in the literature doing that, there are 2 readily available approaches. One is to use the Orvis-Thompson approach. So if I let Pi denote the probability that an event is reported by at least one source. Okay, let me say this again. And I is the number of sources reporting each event. Okay, so the major shipwreck has been reported, I think, by 200 and something sources. The event Alessandro was referring to has been reported by hundreds of sources as well for several reasons. And minor events have been reported just by 1 or 2 sources. And this is an I. Each event is associated with a number of sources. Okay. The probability that Ni is larger than 0 can be estimated if you specify a model. And then Orvis-Thompson theorem tells you that you can estimate capital N just by the sum of 1 over this probability and capital S just by the sum of xi over this probability. Okay, so it's this is standard in sample in statistical sampling, even if they don't have usually biased design, and this is a biased design because we don't have a design. Okay, this is opportunistic sampling. Orvis-Thompson is simple, it's not bad, but it ignores dependence between the number of deaths and the number of sources, and so it's probably biased. And I will show you that in fact it's not optimal. I'm about to introduce a methodology of which Orvis-Thompson is a special case under independence between xi and ni. Okay, well, I will try to model dependence both to exploit the information given by this positive association in this example, but also to remove bias that you might incur if you provide estimates that ignore dependence. Okay. Another approach is a Bayesian approach. There is a paper by a famous paper, highly cited paper by Royle in Biometrics, in which he proposes a Bayesian method for estimating n. So Royle never even thought about estimating a total, but a direct byproduct of his approach is an estimate of the total, because this Bayesian method is based on augmentation, implying that for each unobserved event, you sample the covariate of interest, and in the end, you will have a posterior for the sample, the population size, and the covariate of interest. So Royle ignored this posterior, but it's a direct byproduct which you can use to obtain an estimate. Okay, and I will compare clearly also with this readily available approach. So I'm repurposing an already existing methodology. Okay, my approach.
Can I ask you a question?
Yeah.
There is something which reminds me, estimation of the number of cases or deaths in an epidemic or something like that, right? But I can't picture exactly what would be the sources in that case.
Yeah. So in epidemiology, population size estimation is quite often used. And so in general, what is nice about these methods is that you can get a lot from for not much. So the sources usually are lists of patients that can come from other sources, from different sources. For instance, I have a paper about the prevalence of multiple sclerosis in Rome, in which I received lists of patients from different treating centers. Okay, and given that this is a chronic condition, some patients were overlapping because they were treated by more than one doctor. Okay, so once again, the number of patients that are treated by exactly one doctor, the number of patients that are treated by exactly 2, and you're going to get an estimate of the number of patients that are treated by no one, because maybe they don't have a diagnosis yet.
So did you by chance use something like this also in something like ecology setting when you want to estimate?
Yeah.
Right. So when you want to estimate the number of, let's say, wolves in an area or something like that, you might need their spatial components, stuff like that. But
well, you can incorporate spatial components. There is an area that's called spatially explicit capture-recapture, which try to incorporate spatial components. I have a paper about whale sharks in the Maldives because I went there diving. I was in the boat with these guys that spent their time photographing whale sharks, and so they had a database about in a period of 6 months how many times they saw the same shark. And once again, I tried to estimate the number of sharks that were never sighted. I have a couple of papers on that. Clearly, there were no spatial component there, but there is a lot of work. That's ecology is a strong motivation. Also, especially with animals, because they have issues with animal movements and stuff like that. But it's incredible how much you can do with little. As soon as you have the ability to have repeated measures somehow. Okay, I'll move forward. A limitation of Royal approach is that don't take this in the wrong way, but it's Bayesian. That's a limitation in that you need to specify a parametric distribution for the joint distribution between the number of the number of sightings, the number of sources, and the number of deaths. Okay. And specifying a parametric distribution between two counts, one of which is zero truncated because you have no zeros in the data, it's embarrassing. Okay, so I'll try to specify something that it's distribution free. In fact, my idea is to base the reasoning on the law of large numbers. And the law of large numbers states that the total number of deaths is approximately the total observed in your data plus this expression here, the expected, the mean number of deaths for the events that are not reported in the data times the number of events that are not reported in the data. Okay, clearly, if this is a large number, the sum for I going to n from n plus 1 to capital N minus n divided by capital N minus n is equal to this. Sorry, without the fraction is equal to the expectation. Okay, if x is a random variable because of the law of large numbers. Okay, and similarly, the joint distribution I will specify through the chain rule. So as the product of the conditional distribution of the number of deaths over the number of sources multiplied by the marginal distribution for the number of sources. This is convenient because then you can estimate n as usual. Okay, the only important thing is that you don't use covariates. You don't use xi as a covariate. Okay, because you need to base estimation of the population size completely ignoring the fact that you have a covariate. Otherwise, you won't get to the joint. The joint again, and the math won't. These will not work. Will not apply. Okay. Clearly, I could also do the other way. So ni conditional on xi and the marginal for xi. It would be I will get a similar expression, but it would be more cumbersome than for the estimation. Okay. So while here I can use chow estimator, I can do whatever I want as soon as I ignore the covariate. Okay, with this parameterization, we're expressing the joint in this way. So now my issue is simply, so this is quite standard in the literature. Now my issue is that only that of estimating the conditional expectation of the number of deaths, given that ni is equal to 0. Okay? Because as I said, given that there is an association between xi and ni, when I condition on the number of sources, if I have ni equal to 1000, then probably xi is very large, the expectation is very large, while here this expectation is probably small. Okay, and I call this S0. Okay, once I have this, I can plug in, and I have an estimate for S, and I'm done. Okay, and well, I I don't have information. I can't condition on ni being equal to 0 because that's exactly what I don't have in the data. In the data, I only have events that are reported once or more. Events that are never reported, I don't observe because I'm not able to observe. That's my source of information. But I can estimate xi conditionally on ni being equal to 1, to 2, to 3, to 4. That's the regression part of the model. And then I can extrapolate to m equal to 0. Okay, so that's simply the idea. I can specify a generalized linear model, link function of your choice, and a regression function of your choice, connecting the conditional expectation of xi on the number of sources. That's regression. That's basic regression, because in the data you have the number of sources and the number of deaths. And then you just need to specify well a regression model linking the number, the trait of interest with the number of sources that report the event. Okay. You will estimate this regression model for m equal to 0, and then you will have to extrapolate because 0 is not observed in your data. But you plug in g to the minus 1 phi hat of 0, then that's your s hat of 0. Okay. Clearly, you will have to specify the link and the regression function, but if you specify well, you will estimate the model in an unbiased fashion. A special case is the situation in which xi is independent of m, and in that case, if you also the link function is the identity, you get the Orvis-Thompson estimator as I was promising. Okay, so if you assume there is independence, then clearly you get Orvis-Thompson estimator. If you assume there is some dependence, then you get something that's exploiting this information. Okay. Clearly, the approach is simple because it's a GLM. It's flexible. Clearly, you must choose the link and the regression function, and that's an open issue. That's an issue I've not tackled too much because there is very little sensitivity in the data to this choice. But in general, you could use splines. I will use polynomial regression, meaning that I will have alpha plus beta 1m plus beta 2m m squared plus beta 3m m to the cube and so on. And let's not get to this fact because it's complicated. You could use random effects to deal with unobserved heterogeneity. You could use additional covariates if you have them. For instance, you can stratify events for the presence or not of children, because clearly if there are minors involved that died, the number of sources explodes, reporting at least, fortunately, the number of sources explodes, reporting the event. And so this will improve the precision of your estimates.
So I have a question. About, okay, yeah, well, you're talking about the variance now, but the question is related to this one. So the method that you're using is not like it's not specific to the fact that you miss only the case ni equal to 0. Now let's say that you extrapolate, you forget the case ni equal to 0. So let's say m. Okay, you just remove the case m equal to 0. It's not there. You remove m equal to 1, you remove m equal to 2. You can redo the same procedure and then extrapolate for those other measures as well. So in practice, you can do some sort of validation set approach backwards. I don't know how to say that, in the sense that you can somehow test the uncertainty in that way somehow. Even if, of course, then the errors that you make when you go backward for m equal to m0 backwards, let's say, then they're not independent errors. So when you do an average there, maybe there is some issue. But what I'm saying is you cannot have measurements for m equal to 0, but you can pretend that you don't have measurements for m equal to 1, m equal to 2, and so on. And so you just do your method for m greater than 2, and then test it on m equal to 2, and then
you could actually. It's been studied in the literature, particularly for the population size, not for the total estimation. And for instance, there are people generalizing Chow estimator using the number of the double source and triple source events, ignoring the single source events, and so on and so forth. This is used as sensitivity analysis, as we were more or less suggesting. There is a theorem for Chow estimator telling you that the best you can do is with the classical Chow estimator. And the rationale is as I outlined, the zero source events are more similar to single source events than to three source events. For this case, I have no idea because I haven't checked. But definitely, you can ignore part of your data and use and that clearly will definitely provide something that is more robust, because something that you often have in the data, that's not the case. But something that you often have in the data is one inflation, and referees had me check for one inflation in this data set, probably because also they were keen to be seated, and they had worked on one inflation. But anyway, there is no one inflation in the data then, but that's something often occurring. So the number of events that are reported by just one search is more than you would expect, and in that case, you might remove and check if the relationship holds. And usually it does hold. Okay, but anyway, that's a good idea. It's good for several purposes to do the analysis, ignoring one at a time. Okay, I have closed form expression also for the standard errors. I use the law of total variance, which is standard in the population size estimation word, because the sample size is a random variable. The number of events that you record in general is a random variable because it depends on the number of searches that you are able to reach. Okay, and so if you want to estimate the standard error of n hat of anything, you must condition on the sample size and then add the variance conditional on the sample size. Okay, that's the law of total variance. And I did my math. I used the law of total variance again for this second part. And anyway, after some algebra, I have that the standard error for S is the sum of 1, 2, and 3 addends, okay, which are available in closed form. PI is the byproduct of the estimation step, and hat is the byproduct of the first step when you estimate the population size. So it's doable. There is some math underlined, but it's doable. Okay, I have several settings in the accompanying paper that's already published on the Annals of Applied Statistics. I'm just going to show you one table, nothing more than we will discuss the application, which is the interesting part. And so I compared S hat, which is my estimator, with Orvis-Thompson and augmentation. This is the root mean square error. And the case beta equal to 0 is the case in which Orvis-Thompson estimator is the best. Okay, so in practice, if here there is a model choice involved. So this increase in mean square error that you see is due to the procedure of model choice and to the fact that when you choose the Orvis-Thompson estimator, you have the best. And sometimes my procedure for model choice, which was very naive, I think adjusted as squared, did not actually select in the independence case, and so this led to a slight increase in the root mean square error. This is a very peculiar situation that I don't expect in the data. In the data, I expect some dependence. I expect positive dependence between xi and ni, and here you can see the root mean square error is the difference is embarrassing. Okay, I was actually embarrassed to publish something in which the root mean square error of the proposed procedure is 8 times smaller than the root mean square error of the competitors. This is half here, this is half here, and this is 6 times smaller here. Okay, and augmentation is not good. Okay, for the reason that I was discussing. It wasn't designed for this purpose, and it's heavily reliant on parametric assumptions, which are here. I mean, I couldn't even specify correctly, even in the simulation study, the parametric model. So that's why augmentation actually does not work, even if it can do slightly better than Orvis-Thompson in some cases when there is negative association for some reason. Yeah, this is just to show you that the standard error estimates work. They are not precisely matching, but because S is the number of sources is not fixed across iterations, so that's not actually what I'm actually estimating. Anyway, it's fair. So united data, clearly the covariate is bounded from below by 1, because here events with at least one death, everything else is left out of the data. I did two very simple regression approaches. One, it's a linear regression approach on the log number of deaths, which is clearly misspecified, and the other is assuming xi minus 1 follows a negative binomial, okay, to account for over-dispersion, which clearly is strong here, and to have it starting from 0, I subtracted 1, and then I added 1 in the predictions. In both cases, I use polynomial regression, as I was mentioning before, different degrees from 0 to 6. And here are the results. So Royal estimator gives 60,000 as an estimate for the past 30 years. Orvis-Thompson gives 59,600 something. This is for the linear model. You see, of course, these two coincide. These do not, but there's a reason for that I might discuss if you want. And using BIC, I select a degree of 2. So Ni plus Ni squared for the linear model, and a degree of 2 also when I specify negative binomial distribution. And as you can see, these two estimates are very close to each other. So my method predicts, regardless of how I specify the distribution, more or less 54,000 deaths, okay? While the other two methods are slightly larger, okay? And there's a reason for this. The reason is the outlier. These two methods seem to be very sensitive to the outlier of more than 1,000 deaths in 2015, okay? And this is driving the estimates high for these two methods. My method seems to be this is an unintended feature which might not hold in general, but at least for this data, it seems to be robust with respect to that outlier. The evidence of this is that if I restrict to 2015, their Royal and Orvis-Thompson estimator have a 50% coverage, meaning that they say that the number of deaths occurring in 2015 are twice the number of deaths actually reported, which is not credible.
Can I stop you 1 second? So I want to ask you about the augmentation. What did you do with that?
Sorry?
About augmentation.
Yeah.
So what did you exactly do with that?
Yeah, so for augmentation, you need to specify a distribution for the covariate, and I think I used the negative binomial. I tried different specifications, but given that it didn't work well in the simulation in which it was more or less well specified, I didn't investigate too much, and the referees were not too much interested in Royal method, how it behaved. So I stopped there. Yeah, clearly there are different specifications that you can have which lead to different results. Then you are in trouble with model choice, because actually you don't have much to say I prefer one parametric over another parametric assumption for the number of deaths. And this applies also a bit also to my method, because here I have log normal and negative binomial, and clearly this BIC cannot be compared because they come from a completely different likelihood specification. So I can't tell you if this specification is better than this. What I can tell you is that with this data, you get the same results, more or less. So it doesn't really matter, at least here. So the regression extrapolation method gives 90% coverage in each year, including 2015. So even with the outlier, I had that in 2015, the number of deaths is 10% more than what is reported, even if I have one event of 1,100 deaths. And that's also the coverage for the whole period. So in summary, the undercount is 20% for the number of events and 10% for the number of deaths, because clearly events with many deaths are more likely to be reported and recorded in the data. Let me show you some plots before I give you my my conclusions. This is the events by year. Something happened in 2000. This is Chow estimator is the red one, and you see dotted the number of events that are reported. So apart from something happening in 2000, you see anyway that there is differential reporting here. So the extent of undercount for the number of events is larger in some years and much smaller in other years, okay? And then after 2010, you can also see, and that's a conclusion for public policy, an increasing trend in the number of events, okay? So since 2010 up to 2021, I don't have 2022 in here because I only have 5 months of 2022, but in the 11 years, in 11 full years, 12 full years between 2010 and 2021, the number of deadly events for people trying to enter Europe have increased steadily. Accordingly, you see a trend in the number of deaths by year. Okay, you see here that there is this major extent in 2015, but anyway, there clearly is an increasing trend. And you see that apart from, let's say, between 1998 and 2005, more or less the extent of undercount is limited, and it's about 10% we can estimate, okay? This is lethality. Lethality, I define lethality simply as the number of deaths per event. Okay, deaths per event. You can see it ranges from 0 to 25 on average. Okay, and also for lethality you see a trend. And this is happening because boats are larger and larger and more crowded, because every refugee trying to reach Europe pays traffickants to jump on the boat, okay? And so they cram the boat with as many people as they can, and they try to get larger and larger boats, because then they go and that's all money. Okay, so more than 50,000 died in trying to enter Europe between 1993 and May 2022, and things are steadily getting worse over time, despite a lot of discussion in Europe, and despite treaties, despite different things that have been tried. Migration is a very difficult and very complex phenomenon, which is unfortunately associated with injury and death. And clearly these risks must be reduced from a public health, from a global health point of view. That's not up for debate. How can you tackle this problem? Okay, that's not my opinion. I clearly I have my opinions, but I try to report what I found in the literature. So I read, as a statistician, reading political economy literature is a bit tedious, but I found interesting stuff. Now, experts agree that one way to proceed is simply to provide regular and safe pathways. Because if migrants know that they can rely on regular safe pathways, then they wait for those. When obtaining a visa is simply impossible, then that's when these phenomena start and persist. Also, clearly, mechanisms for relocation must be foreseen, because in some cases there must be relocation, and these mechanisms should respect needs, safety, and choices, and also obviously should respect human beings. Now, to summarize this, I don't usually trust simple solutions to complex problems, but I literally heard experts say you should simply grant visas. That will solve the problem. I'm reporting what I heard. Clearly, more complex actions and other actions, they are collected in a nice book by Shil Hav, in 2017, one point that is stressed a lot is to work on a respectable public debate that is also based on evidence. Okay, and when I say evidence, that's where statisticians and data scientists come into play, because often the public debate is not based on evidence, and often, especially, well, I can't say, but often I see public debate that is not respectful, and that is bringing about death of people. The laws should be designed that aim at increasing the benefit that migration can carry for everyone, so for migrants and also for populations already residing in the final destination. Clearly, promotion of development aid in the countries of origin is an important action. That's something right-wing politicians in Italy often say, help them at home, and everybody agrees, only then help them at home. Then avoidance of certain things. One is avoidance of agreements that reduce direct national and responsibility for the European Union, in this case, for hosting and protecting asylum seekers. There have been agreements between Italy and Libya, for instance, that are not helpful in this matter. And sanction unethical laws. Some unethical laws have been passed recently in Italy, and that's a direct consequence of the laws that have been passed in the past month, is the more or less 100 deaths that occurred in Crotone last week. Because this, if you look in the map, Crotone is north. It's very far north. And the reason why these people were trying to go to Crotone is a direct consequence of some laws that have been passed. The European Union can and should sanction countries that pass unethical laws, which can be clearly marked as such. The same I expect can happen in the US with the federal government that can monitor agreements and laws of the states, but I'm not absolutely not an expert in the subject matter for the US, and not even for Europe, actually. I'm almost done. Technical conclusions. The method I proposed enjoys good theoretical properties. I have not given you theorems and stuff, but it's obviously unbiased under correct model specification, so there are no undercount issues with the method I proposed, if the model is well specified, which is a big open issue. The use of media content leads to cheap and quick data collection, and this solves the time lag issues. You can set up data collection in real time, even automatically. You can do a web scraping with the script. The method is simple, so in principle you can update your estimates up to yesterday, every day, with an automatic script, which should be monitored. And my third critique related to standard errors. You have standard errors in closed form, and we should get the habit of reporting them. A strong limitation is that I have assumed total casualties to be measured without error. That is not the case for sure, and it's. If you look, I receive updates from United for Intercultural Action every year, and if you look at past events that were already reported, they often change the number of casualties because they realize that there were more than they actually could reach, and so on. So even what I have might be an underestimate due to measurement error. A limitation for other applications is the fact that I rely on the law of large numbers for my theoretical properties. And if your desired summary does not involve a sum, so let's say you wanted to investigate the median number of deaths instead of the total number of deaths, the median number of deaths per event, then it could be cumbersome. It does not directly extend, and it might be ground for further work if I'm stimulated by a nice application. Another open problem is model choice. So I used BIC, but that is certainly not a good idea. Recently, some colleagues and in another paper myself have explored the use of focused information criterion, which is an information criterion trying to minimize the expected mean square error for the estimate. That could be a good idea, because clearly it's model independent, it's distribution independent. You just have an estimate of the expected mean square error. But I have not worked on this. The possible extensions are for multivariate traits, more fancy models, and so on. But yeah, and that's it. That's all I have to say. Thank you.
Thanks a lot for the great talk. Well, I have a bunch of questions. I have maybe I want to say a couple of comments. So you mentioned about Crotone and so on, right? So it's people might not know, but the part of Italy which is most south is I don't know how to say southern than the northwest part of Africa.
Yeah. Lampedusa.
So Lampedusa is just very, very, very southwest of Africa, right? So you can see it there. While Crotone, you have to do a little bit of you have to go. Is to pass part of Sicily and so on, right? So there is a lot of space between one and the other. The other thing is comment on this that we may not completely realize it, but the north part of Africa, at least, it's like Italy. Like it's like us. Like you go there, you see the cities. They are not that different. We don't know that. We don't think about that anymore. But there are many parts in of the Mediterranean countries. I don't know how to say that. They just look like Italy. Like if you go there and see temples, which you can see in Rome, you go there and see like cities, part of which like look like they're Italy. We just don't realize that. So we think about something which is very far. But when they destroyed Palmyra's temple, something like that, we don't think about that even in Italy. Like, we don't feel like that. We don't feel like it's us there, right? It's not. We don't feel like it's us dying there, right? It feels that it's someone else. It's someone else, but it's not someone else. You go there, it's like home. There are many people actually there retiring in North Africa or something like that, but it's like home. Now related to a more maybe one technical question. methodological question and super important operation topic. So thanks a lot for bringing these things to us. Thank you very much.
My pleasure. Have a good day.
Stop the recording.